So as we know in last class, I explained alpha rays scattering experiment. How many of you understood experiment clearly? Really? I want a response from you all. Is it correct? Have you understood or not? All of you?
Yes, sir.
Yeah. So in alpha rays scattering experiment, mainly he has been predicted something what he has been predicted, but his results is like beyond expectation. So he expected something from the experiment, but he noticed it. Unfortunately, most of the particles, they are, after bombarding the gold foil, they are going away from it. Yes or no, everybody? So to do this alpha ray scattering experiment, he has chosen the alpha particles. What is that alpha particles? Anybody can tell me? Yes, please. Alpha particles are what? Yesterday also I explained you. What do you mean by alpha particles? They are the
Positively charged.
positively charged which ions?
Helium.
Helium. Helium nuclei. That is what? He2 plus. Sir, why he had chosen these alpha particles? All of you remember, whenever we remove the electrons from these stable atoms, so these ions, that is what He2 plus ions, they will get the enough energy to penetrate through anything. So that is the reason he has chosen these alpha particles. So the fast moving alpha particles, they are having a considerable amount of energy, so they can penetrate through the matter to some extent. That is the reason he has chosen the alpha particle. Understand, Harish? So that is what it is taken. So in his experiment, what he has taken to emit these alpha particles fastly. So he has chosen something which we is to call. Anybody can tell me what is the name called as? To emit these alpha particles fastly, he has chosen something that is what we is to call. Any one of you? Yes. What Mithak say?
Silt, sir.
Silt is to pass that alpha particles through a particular point. To emit alpha particles, he has been taken a source. What is the source called as? Radioactive source. Do you remember that? Yesterday also I written. So that is what we can say, even a radium. So that is what has been taken to emit the emit the alpha particles, and they are passing through this small slit and they are keep on moving. So here he has been arranged 1,000 atom thickness, a very extremely minute thickness, 1,000 atoms one. That is what we used to call as a foil. What is that foil called as? All of you. What is that foil?
Gold foil.
Yes, it is called as a thin foil, which is made with what, Mr. Johan? A thin foil of gold, which is almost thickness equals to how many atoms, guys? Thickness of 1,000 atoms. And he has been arranged a screen surrounding by that. So what is that screen called as? It is made up of something, the screen. Screen is made up of something. So we can see that a bright flash. So what is that called as? Circular zinc sulfide coated. Do you remember? Everybody forgot it, I think. So zinc sulfide coated has been surrounding by this gold foil. So these alpha particles will go and hit. So most of the alpha particle, he expected that alpha particles are bigger than gold atoms. So most of them, they will come back. But surprisingly, he noticed that most of the particles passing through this gold foil and they are deviating in a certain angle. That is also noticed by not Mr. What's his name? Rutherford. It has been noticed by his assistant. What's his name? Assistant name? Anyone? Yes, please. What is the assistant name of this one?
Giger.
Hans Jaeger. He is the assistant of Rutherford. He is the one. First, he noticed this one, and that is what the discovery of nucleus leads to discovery of nucleus. So this is what the experiment which we studied in the last class. So very few alpha particles only turning back. So that is also how much also we'll study. So how many particles he projected for 1 second and how many particles returns. Everything we can there. Even advanced missions are there. We can count that also. So very few particles turns back. But what is the expectation of Rutherford? What he expected actually? What is the experiment? What is the expectations on this? What he did? He did not expect such large deflections. Why? He assumed that alpha particles are heavier than alpha particles, much heavier than protons. So he expected that alpha particles would be deflected by these subatomic particles present in the gold, but you can see is not expected such large deflections. He expected almost all the particles will be come back, but in experiment, surprisingly, more than beyond his expectations, instead of returning back, most of the particles are penetrating through the gold foil and they are going and hitting this compound surrounding wall. That is what major you can see. So, and they are producing like a bright flashlight, a bright flash on the screen. That is what a blue color screen back here, coated with what? A zinc sulfide coated. And you can see very few particles, major deflections. He expected that very few particles, most of the particles will turn back and very few only will take deflections. But here, the deflections also less than 10%, very few particles only taking the deflections in a major part like more than 90 degrees. Majority of the alpha particles, the angle is just greater than 10 degrees. It's not more than heavy deflection. That is what there, it is like entirely different compared to this one. Okay. So if you notice this is what the experiment is connected by Mr. Rutherford to discovery of nucleus. So during this experiment, let us observe what is his observations he made himself. So totally he made 3 observations. So that what is the 3 observations we'll write now. From the observations, he made some conclusions derived. From that, he formed the theory called as Rutherford atomic model. So first of all, let us see observations. What is this observations? First, you can notice in the picture also, most of the alpha particles, is it they are deflecting or they are passing through the gold foil? Anybody?
Passing through the gold files.
Passing through the gold foil. That is what he noticed the first observation. Write it. Majority of the alpha particles were majority of the alpha particles were passed through the gold foil without any deflection in their path. Without any deflection in their path. Yes or no? Next, he noticed it. Have you noticed it? Here and here you notice. If you imagine screen is here, okay? So very few particles only showing the larger deflection. Have you noticed it or not? I mentioned here also. So yesterday picture if you are having, you can see few alpha particles. They are showing major deflection. Clear? So that is what it is. He noticed it. Very few only they are showing completely major deflection. That is a second observation. He has been noticed it. a few alpha particles were deflected, okay, with small angles, with small angles, and a few with large angles. Okay, next. He noticed one more surprising result. A very few actually is bouncing back. Have you noticed that? Exactly bouncing back. Have you noticed it or not? All of you. So that how many, sir? He used to count that after every 12,000 alpha particle, one is turning back in the same direction. So that is what he noticed it. Very few. That is what? 1 out of 12,000. Are you understand, all of you? 1 out of 12,000 just turned into what? Turn back in the same direction. So this is what the observations made by Mr. Rutherford during his alpha rays scattering experiment. 3 observations. Anybody having anything doubt? Please ask me. Are you clear, guys? Yes, please.
Yes, sir.
Yes, sir.
So now let us see this. So very few particles, majority of them, they are going straight line. Very few particles are showing minimum deflection, like small angles, and very few with the large angles deflection, and very rare, like 1 out of 12,000, it is bouncing back in the same direction. So this is what observed by Mr. Rutherford during his experiment. So, and this is the scattering of alpha particles by the atoms of gold foil. So if you notice it, he has taken almost an extremely minute thickness of gold foil, almost 1,000 atoms thickness. So that is what he has been assumed. Here you can take, this is what actually the gold foil. Okay, now these are the only positively charged particle. So what is this particles? Anybody? What is this particles called as? Yes, please. Alpha particles.
Alpha particles.
Yeah, alpha particles. Now, if you notice it very carefully here, very few particles is showing the large deflection. Have you noticed it here for showing the large deflection? Yes or no? Next, very few very few particles showing the small deflection. Small deflection. Now, most of the particles, they are passing in a what line? Have you checked it here? Most of the particles, they are passing in a what lines? They are passing in
Straight lines.
straight lines. And very few, 1 out of 12,000, every time, 1 out of 12,000, he has been noticed, turns into what? Turns into back. Turned back exactly. So these are the 3 observations he noticed it. So from this only, as he is passing positive charge, understanding? So when this positive charge is hitting this another positive charge, as we know, positive charge and positive charge, like charges or unlike charges? Anybody? Yes, please.
Like charges.
Like charges. So, like charges will show attraction or repulsion.
Repulsion, sir.
Repulsion. So that is what he understands, that whenever the particles are hitting a similar charge, alpha particles are hitting the similar charge, they are showing the deflection, maybe a small deflection, because a particle is going closer to the positive charge. Yes or no? Have you checked it here? It is moving closer to the positive charge, small deflection, and almost touching and going, large deflection, exactly coinciding. It is like exactly turns back like this. You understand that majority of the alpha particles going in a straight line means he assumed that the atom is having larger empty space. Understanding? So that is the reason most of the alpha particles are going in a straight line. And somewhere at the center, extremely small, somebody is present. That is what it is, a positive charge. He called as, what is that called as? All of us. It is called as nucleus. So, and he said, atoms, a nucleus is extremely small, which is located deeper inside the atom. So that is why it is called as nucleus. So because of that, it is showing deflections. As it is contains the positive charge, it is showing the deflections. And the electrons and all, always they are revolving in a particular orbit, and as we know, they will show attraction only towards the alpha particles. So that is why no deflection is shown when the alpha particles are passing, understand, below or above to the nucleus. So if they are moving closer to the center, then only he noticed the deflections is taking place. So from this, he made some conclusions. After these three observations, he made totally 4 conclusions. Let us make that conclusions derived by Rutherford. Have you understand this diagram, everybody? Your book diagram is very confusing. If you want, you can take this diagram. It is extremely fine. So it's very beautiful also, and very nice diagram. If you want, you can draw this diagram in our classwork. Please kindly make it. Understand, Mr. Aswin, Omar, Noor? Anything doubt, please kindly let me know. All of you understood or not?
Yes, sir.
Yeah.
Yes, sir.
That is what it is. So 3 observations. Small deflections, large deflections, same way. Most of them, they are passing straight line. And out of 1 out of 12,000, he noticed it what? 1 out of 12,000 particle. He noticed what, guys? Yes, please. What he
Want
noticed?
to be rebound.
Yes, it is rebounced or it is turned back exactly. So that is what it has been happens. So these are the 3 observations made by Mr. Rutherford during his alpha rays scattering experiment. This diagram you have practiced. Exam surely they will ask you, as it is very important one. So kindly focus on it. Okay. So this is what it is. Now let us discuss what is the conclusions derived by Mr. Rutherford. Write it. First conclusion. So he found, what is the observation? First observation. Tell me, everybody. All of you read. First observation. Yes, please.
Sir, most of the alpha particles are passed straight to the gold foil.
Yes. So from that he said, most of the atom is empty space. Understanding? So that is what the first conclusion derived by Mr. Rutherford. As majority of the alpha particles passing through the gold foil undeflected, means without deflection, so that if gold foil is a solid throughout and made up of atoms, but atoms are not solid throughout their volume. They are like a halo spheres. So that is why alpha particle, of course, gold is a solid, but atoms are not solidified like this fully solidified one. So they are having fully empty space. Do you understand, all of you? Kumar, Noor, that is what you have to remember it. So gold is a solid. It is fully made up of atoms, but these atoms are not fully made up of like a solid. They are having a empty space. So that is the reason majority of the alpha particles are passing through them. That is what the first conclusion made by Mr. Rutherford. Is it okay, everybody? Have you understand or not? Aswardham, Abhiramit, Danishkar, anything doubt, please ask me. So that is what the first conclusion, right? Most of the space in an atom is empty. How he concluded this? Anybody? How he has been made this conclusion? Because majority of the alpha particles are passing what? In a straight line. That is what it is. So most of the space in an atom is empty. Please write. Explanation. A majority of or a major portion of the space in an atom is empty, as most of the alpha particles please remember, most of the alpha particles passed through the gold foil, deflected or undeflected? Yes,
Sir,
please.
deflected.
Undeflected, not deflected, mister. Undeflected. That is why he concluded it is empty space. That is what you have to remember. Okay, right. Gold foil is solid. Gold foil is solid throughout and made up of atoms.
Sir,
Ah,
sir, did this alpha particle passed through the nucleus or above the?
is not passed through the nucleus. They cannot pass through the nucleus. Understand, Noor? Because nucleus
Okay,
is a
sir.
positive charge. That is why if they are hitting exactly the nucleus, bouncing back, closer to the nucleus, some deflection, or touching the nucleus, larger deflection. If they are not touching or not passing near to the nucleus, empty space. So that is why they are passing the straight line. So that is what he noticed it. So most of them, they are going in a straight line without any deflection. So that indicating that what? There is nobody is there to stop them or divert them. Understand?
Yes, sir.
Empty. That is what from that only he made it. It is empty space. Clear?
Yes, sir.
Okay. Understood or not?
Yes, sir.
That is.
Yes, sir.
Yeah. So please make it. If you have doubt, please kindly ask me. Don't hesitate to ask. I will explain anything many number of times also. I don't have any problem. So right. Gold foil is solid throughout and made up of atoms. But atoms are not solid throughout their volume. Clear, everybody? Yes, please. So it was concluded that most of the space in atom is what, guys? Empty or filled with anything? Most of the space in an atom. Yes, please.
Empty, sir.
Atom is empty. That is one. Please write. Next, second observation. What is second observation by him? All of you read. Yes, please. What is second observation? You should tell me. Danishkar, read the second observation. Yes, Nimish. Kaushik. Is there? I'm not asking you to say your own. Is there here? What is this? A few alpha particles were deflected with small angles and a very few with the large angles. So means the sense of he already knows he is sending the positive charge. So when they will repel each other, when they're hitting the same charge or opposite charge? All of you.
Same charge.
Same charge.
So that is why he concluded that at the center, positive charge is there. That positive charge only we can call it as, what we used to call that positive charge? What is that called as that positive charge? Proton. So, and he said it is at the center. That is why it is called as nucleus. What is that called as?
Nucleus.
Nucleus. That is what you have to remember. Okay, right. Second point. From the observations only, positively charged nucleus at the center. How he found this? Because the particles hitting at the center is showing deflections. Yes or no? All of you?
Yes, sir.
Reason. So from that only he made this. That is, you must write. Right. Alpha particles are positively charged. Alpha particles. Anyone having doubt, please ask me. Write the notes properly. Alpha particles are positively charged particles, and we know who will shows repulsion. Same charge only will shows the repulsion. We know that same charge repel each other. So by the observation that some alpha particles rebound out of how many? Out of the one out of
12,000.
12,000 or get deflected from their path. He concluded that in a central part of atom, that is what small region of atom, positive charge is concentrated. Positive charge is concentrated. Clear, everybody? So that is how, and that's the center, what we used to call. What is this called as? He called something. That part only known as what? All of you. Known as?
Nucleus.
So for this only, he got the Nobel Prize. In which year? All of you? For this, yes, for this only 1908, not 48, 1908. Clear, everybody?
Yes, sir.
Yes, sir.
Clear, everyone? That is what it is. Next. Now, as he noticed it, very small region only it is showing the deflections. So whenever he passed the alpha particles, The deflection is showing by very, very extremely small region of the atom. So from that, we can say very small, the size of the nucleus is what? Is it big or small?
Very small, sir.
Very small. That is the third one. Very small size of nucleus. Right. Third conclusion. Right. So this is also based upon the second one only. Second observation only. Clear, everybody?
Yes, sir.
Yeah, right. The size of a nucleus is very small. The size of the nucleus, the size of a nucleus is very small as compared to total size of the atom. Radius of the nucleus is found to be 10 power 5. What do you mean by 10 power 5? 1 lakh. Have you noticed it? All of you?
Yes, sir.
Yes. 10 power 5 times smaller. 10 power 5 times means how many times smaller nucleus? 1 lakh time almost. Understanding? So 1 lakh times smaller than that of an atom. Everyone clear? So actually, it was shown by deflection of very small number of alpha particles by the gold foil. That is the reason from the small portion only deflection. That is why it is proved and it has been calculated later. It is 10 power 5 times smaller than the size of the atom. That is what you have to remember. Next. Last one. This is, you people might be not notice, you can write it. That is bouncing back. So very few particles are bouncing back. S are now completely rebounding. So that the nucleus is very thicker. Thicker means high density it is. So it is not at all allowing to even penetrating somehow also. So that is why it is very strong and having high density nucleus. So nucleus, high density of nucleus. So make it high density of nucleus. Understand everybody? Yes, please. Right.
Sir.
The nucleus has a very high density. The nucleus has a very high density. We are having surplus time. You no need to worry about time management and all. Once this over, then only one more Bohr's model only remaining. After that, what else is there? Nothing. Isotopes and isomers will finish in one day. That is what I can say. Okay. So no worry about things. You can only learn how much you are gaining the knowledge is only matters for me. Very high density. It was shown by the rebounding. Third property, it was shown by actually this is a third observation. It was shown by the rebounding of alpha particles. Of alpha particles, as it does not allow does not allow alpha particles to pass through it. Nimish, understand Nimish? Danishka?
Yes, sir.
Pass through it. That is what you have to remember. Okay. So on the basis of calculations, let us make how much size. On the basis of calculations, again join back in the meeting. Don't leave. Okay. Calculation. So Mr. Rutherford found it. How much it is, nucleus and atom. Found that the size of nucleus is 10 power minus 15 meters and size of atom is 10 power minus 10 meters. So who is bigger, 10 power minus 15 or minus 10? Minus 10.
Minus 10, sir.
That is the number. Okay. That is why nucleus always how many times smaller? 10 power